Hey, we're on section 3, Swyk 1. There is only one Swyk and one assignment for this section. I didn't have enough problems that I felt like I justified 2 different Swyks. Okay, so why the heck did I throw this question in here? I've done this one before. Well, Math Excel has this really weird thing where it won't allow you to pick questions from other books unless you have one question from the book you are currently operating out of. There's hundreds of books, but most of your questions, or you have to at least have one question that comes from the current textbook before you can pick others. So I had to pick one. It's an exponential growth function, and none of the other ones, none of the other ones look like exponential growth functions. So just had to have my one question. Now, y equals ab to the x. We're familiar with that. But there's a compound interest formula that I'm trying to show you in this example. It's exactly the same function. It just looks different. The amount of money that you're going to have after so many years, that's what A represents. That's how much you're going to have left at the end. P represents the principal, right? That's how much you've been given. I don't think that's spelled correctly, because I thought principal was your principal at your high school. Like, that's, PAL, like it's a pal, like it's a person. Okay, I think they misspelled it. I'll have to check. Anyway, that's the amount you're starting with. In this case, they're starting with $3,200. Now, the interest rate, 6.5%. I don't know where they're getting that from, but it's must be a pretty risky investment to get that kind of interest. But that's your R value here. And yes, you have to change it to a decimal, 0.065, right? And when you add it to 1, you get 1.065. And we're raising it to the 17th power. We're using Desmos. Hold on, let me switch over. All right, let's type that. Oops, let's go up 17. Okay. $9,334.55. 9334. 9334. 9334.55. So, not quite triple your money, but definitely a nice return. The interest earned in 17 years. Oh my goodness, I didn't pay attention to this question. Interest earned? Well, I'd have to take that 9334.55, and I would have to subtract $3,200. Now, why would I ever want to know this? You don't, but the government wants to, because they want to take your money and tax it. So using our handy-dandy calculator, oh my goodness, why can't I find my calculator fast when I need it? Gee whiz, 9334.55 minus 3,200. I cannot type. 9334.55 minus 3,200. There we go. 6134.55. Yeah, the government wants to tax you on that $6,000. They want their money. Okay. Question 3, a transport company purchased a truck for $82,000. Okay, so we're starting out with $82,000. We are decreasing or losing 13% of the value. Vehicles depreciate. They go down in value. Now, I want to zoom in on something that's really super important. Remember I told you every percentage starts out at 100% and either goes up or down from there? Well, this time it's going down 13%. That means we land at 87%. Okay, now zoom out again. Well, that's where the growth factor comes from, 0.87. And we know that we're talking about the 8th year, so that's why I put an 8 up here. Let's go find out what it is. So 82,000.87 for 8 years. 26,913 and 36 cents. 26,913. 26,913. 36 cents. Now, the next type of problem that we're having for this this different Swyk is called a half-life problem. One of the things that you need to know is when we talk about a half-life, the growth factor, that's the B value, is always 0.5 for half-life. Kids always are saying, "Well, Mr. Staley, it never says what the growth factor is for a half-life." Well, yeah, it does. It says 0.5, half. Okay, now, with that being said, how much do you start with? Well, typically that's this number that's out in front. Since this question is asking about a percentage that we're losing, we're going to treat this a little bit differently. We're going to start with 100%. Now, so this number 1 really represents 100%. It's the decimal form of 100%. So that's what we're starting with. And we have a half-life of 4 minutes. That means every 4 minutes you're losing half the value. So you'd start out with 100%, then you'd go to 50, then 25, then 12.5, then 6.25%, then 3.125%. You're just cutting it in half every time. Since the first 4 minutes would be 50%, you can't say the next 4 minutes is going to be another 50% of, the original, because that would take you right to 0. It's 50% of the previous amount. It's kind of how cars work. The value of the car can never be 0 unless it has basically evaporated into dust. But if there's an engine block, you can recycle or scrap metal. Even if it's a piece of junk, you can still push it out for scrap metal. Now, so starting with 100%, we got a 0.5 for the decay rate. We know that the half-life is 4, and they're asking me how much remains in 1 minute. How much are we losing every single minute? I know in 4 minutes I'm going to lose 50%, but how much am I losing in 1 minute? Now, you go to Desmos, you come in here, and you type a 1, right? Look at what it says. We're down to 84%. We started at 100%, now we're down to 84%. So how much did we lose? We lost 16% in 1 minute. And if you do 16% for 4 straight minutes, remember, it's multiplication, it's not addition. It's not addition. So don't look at me and say, well, 16% for if you do that 4 times, that's 60, what is that, 64? No. But if you do that 4 times and you're doing multiplication, you end up with 50%. I mean, it's real close to 16%. Might be a touch over or under. I can't remember. I'd have to look. All right, now, in question 5. Current population of a threatened animal species is 1.5 million. Yes, our answers are going to be in millions. I'm not writing out the entire thing. Okay? I really hope they're not either. To be quite honest, you're going to have to check on Math Excel, because all it says is to the nearest whole number. I'm like, please don't make us, write out a big number here. Okay, so the half-life growth factor, 0.5, we have a half-life period of 25 years. That's the denominator of the fractional exponent. And we're going to start off with plugging in 40 years, and then we'll go to 70 years. So let's jump over to Desmos and do that. So here we're plugging in 40. And that's, so we're down to less than 500,000, right? We're going to go, I guess, you know what? I guess they're going to make us convert that. So I guess you could do this. We could, instead of using 1.5, we could use 1500123. So there is 1.5 million. So to the nearest whole number, we would have 494,815. 494,815. So I guess we need to change this to 1. Now, typically when we're doing these kind of problems, we don't make you change it, but Math Excel might. So you might as well do what they do, thy bidding, I guess. So here we're going to change it to 70, and now we're at 215,381, rounding to the nearest 215,381 to the nearest whole animal. Yeah, we don't want partial animals. It's gross. Okay. Question 6. I know this is kind of a longer Swyk, but I guess I could have split it into 2. I didn't really think I should, but maybe I should have. We've got half-life of 83 days, so that's going to be the denominator of the exponent. We're starting with 1 kilogram. That's the starting amount. So instead of being a percentage, it's actually an amount of kilograms. Growth factor always 0.5, so we're going to start with 170 and then move to 340. Okay, so 170 means we're at 0.2418. 0.2418. 3 decimal places, 0.242. Okay, 0.242 if we're going to near to the thousandths place. And then change it to 340. 340. So 0.058. 0.058. So we doubled the number of days, and now we're all the way down to less than a tenth of a kilogram. Okay, question 7 is the last one here. A radioactive isotope has a half-life of 24 years. Okay, that means it starts with 1, and then it goes down by a half every 24 years. So after the first 24 years, it's down to 0.5. After the next 24 years, it's down 0.25. So you can see that I'm not dropping the same amount. I'm dropping the same percentage. So in the first 24 years, we're dropping 0.5. This says determine how much we will lose in the next 24 years. Well, that would be 0.25, which is why it is choice D. 0.25 will decay in the next 24 years because this is half of the isotope that is left after the first 24 years. Okay. Time to go do the Swyk and the assignment, and then be ready for a test. See ya.